So here again, I haven't graphed the functions, so let's start by that. I'm going to graph this one in orange, and it is a straight line, y equals x, with a slope of 1, and y equals the cube root of x. You might want to do a table of values. You could use all your calculus skills to graph it, or you could take a graphing calculator and make a quick sketch too, because I really would just want a rough picture. And the cube root of x looks like this. So what we've got here is I want to find the area sandwiched in between these two curves. So there is the area here and the area here. So I could double my efforts and do the calculation twice, because notice the function on top is different. In this piece right here, it's the orange that's on top, and in the second part, it's the purple that's on top. But it's a symmetric function, and it's an odd function, and that means that if I calculate this area right here, I can just double it to get the entire area. So that's what I'm going to do, because it's way more efficient. And what I first need to do is figure out what these 2 points are here. And this one is 0, so let's solve for the other one. I'm going to let x equal the cube root of x. To get rid of the cube root, I am going to cube both sides, so I get cube root equals x. Bring the x over and factor, so I get x and then x squared minus 1, and that gives me actually 3 roots, which we would expect because we have 1 here, the 0, and the -1. And that shows you again that it's a symmetric function, because the two intersection points are the same distance from 0. So I am going to integrate, since I'm only finding the area of the light blue, the one on top is the cube root function, and I'm going to subtract the straight line, and I'm going to go from 0 to 1. So before I integrate, I'm going to write this as a exponent, and now I'm going to integrate. So I'm going to take this exponent and raise it to a power of by 1, so that's 3 over add 3 over 3, so it's 4 over 3. Divide by 4 over 3 is the same as multiplying by 3/4, minus x squared over 2, evaluated between 0 and 1. So plugging in the 1, I get 3/4 over 4 minus 1 squared over 2, and I subtract 0, which means I'm going to subtract nothing. So I'm now simplifying. The cube root of 1 to the power of 4/3 is 3/4 minus a half. So that's 3/4 minus 2/4, which is 1/4. So this area is a quarter, which means the entire area is a half, because you've got 2 of them. A quarter plus a quarter equals 1/2. There we go.